So I wanted to do a video. I don't know if this is something people know about or, really have ever played with. It's something I used to use a long time ago. I haven't heard about it in a long time. It can be really fun to play with. It's really good for getting an idea of what types of engines make what power. I originally got it because I couldn't afford a dyno when I had a Thunderbird Super Coupe that was modified, and very modestly it was a lot of porting and very custom, which is actually a hard figure to put in. It's hard to use something like this if you're doing that without a flow bench, but anyway, that's why I originally got it, and when I set about to rebuild and do kind of a performance build for the 5.0 in my van, is I looked for this software again. It's old enough, it's from like 2001, to where you can usually find it for free. I don't know if I'm a pirate or not, but anyway, so it's Desktop DYNO 2000, and basically this will allow you to adjust every single parameter from dimensions to airflow, to what head gasket you're using to calculate your actual compression ratio. I already shot this. This is a reshoot. I'm going to try to go through this faster without going through everything. So here you can choose your block, and there are a number of blocks from like every manufacturer, major manufacturer. And the only things it won't have, if it's bored over, then you have to know at what amount. This is obviously a 30 over, so it's a 306. And if you're doing a stroker, then you're going to want to be able to know the stroke. For cylinder heads, it's a little different. You do have to have your valve sizes, and sometimes you have to plug it in twice. So this ends up being a custom airflow because I had flow bench numbers of someone else that ported E7 heads, but maybe they were kind of fooling around, so mine, I'm not saying they will, but they may flow more or less, but I wanted a conservative value, so I just used his numbers and messed with them a little bit. So always make sure that the valves get put back in here. I don't know why that's 782, it should be 780. But you can see you have all your cam lift numbers, and then your flow value, which these are very modest E7s that are ported, from 200 thousandths all the way to 710 thousandths. Again, maxing out at 210 to 160, and notice that I stopped plugging it in at 500. One thing to note, GT40 and E7 heads, they really don't gain anything from lifting more than 500 thousandths, and that was part of the reason why I did the cam selection that I did, and kind of built all the ideas around that one thing, being the limiting factor, the ceiling of the stock iron heads. Because a lot of people will choose a camshaft based on sound. They go by lift numbers, to basically kind of thinking that they're maximizing when they're kind of wasting valve events. And the higher lift values that you have, I mean, yes, there's asymmetrical lobes now that let the valve down a little easier on the seat, but that's still a lot more wear and tear, and then you have to have a heavier spring, and that's going to put more wear and tear on the lifter. Even if you have a heavy-duty lifter, it's still just more weight overall. So, this is a Truck 5.0, it's EFI. It uses the dual throttle body, the tall plenum. Those long runners are for low-end torque. I have a BBK, I'll show photos of that, a BBK dual 61 millimeter, so it's a lot of airflow. 122 millimeters is like, that's like an aftermarket throttle body for the last generation GT500. So I had to port match that throttle body. And then I opened up, and I'll show photos of opening up the dog legs. I'm just gonna block the numbers for now. To get an idea, I have my compression set at 9. Realistically, with the pistons, it may be an 887. If I run a particular head gasket, it'll be closer to 9. So you can plug in those values. You can plug in a custom value. You do have options for manifold there. Of course, now that's not letting me. So SFI would be the closest thing to electronic fuel injection, and obviously single, dual. You can even do tunnel ram, individual runners, TPI if you have like an old 3rd gen F-body or something, and forced induction. So SFI is the closest. And you can see all the forced induction options to give you a good value. Even nitrous oxide, which I've never really played with, no need. I typically do my runs with open exhaust because there's no way to know what... I think it's used as a regular muffler. So it's not necessarily a 2-chamber, a cherry bomb, so it's a little vague. And you obviously can't put in if it's a 1/5/8 primary or 1 3/4 and so on. The camshaft, on the other hand, being the brain of the engine, this allows full control. And you'll even need, like, here's my cam card from Lunati. This is a bare bones, it's a hydraulic, it was only like $130. So you can choose the camshaft type as a general variable, like stock, high performance, and so on. Whether it's hydraulic, roller, or just solid flat tappet. And then you can save the cam files and so on. You can do your specs at seat to seat, which is your advertised duration, or you can do it at 50 thousandths inch timing. Again, this camshaft selection for this build, it's still high performance lift, maybe a little under like an E303 or B303. But definitely a higher duration. My advertised duration on my cam card is 281, 293, which is getting a little more on the high side, and a bigger duration is better for higher end power. So I thought it would be cool to take the characteristics of the low end power of the plenum and kind of mix it up a little to squeeze out high end to be a little more exhilarating on highway and stuff, but it still has a lot of low end power. If you have like a timing chain like mine, like a double roller from like a Magnum from Comp Cams that has timing adjustment, you can put those figures in, so like 4 degrees advanced and so on. And then you can get your timing events, so like intake valve opens, intake valve closes, that's IVO, IVC, obviously exhaust valve, and so on. But that's not all. You also have these tabs. So cam math, port flow. This is, well, I showed you that already. That's if you have flow bench numbers, or at least an average of what people get, you can play with that. That's a lot of fun to see if it's worth it going from a 500,000th inch cam to a 540. And a lot of times with heads like these, you'll see it's not even worth 5 to 10 horsepower. So even though the cam costs the same, is it worth the wear on the valve train? Okay. You can do your cam math, you'll need these figures. So again, it's everything is going to be on a cam card if you already have the cam. And obviously you can play around by looking these numbers up. So this happens to be a 112 lobe separation angle, or lobe center angle. The center line 107, and then again my advertised duration and exhaust. Now if you set this to 50 thousandths, these are going to be more like 215 and 224. The reason I do seat to seat is because this particular cam has a higher advertised duration. So this is a fairly streetable, snotty cam profile. Not so, but once your duration gets up a little higher, this is nice. Like, this would definitely work well in a car. But it's going in a truck, so that's why it's, you know, modest values, and I thought it would be cool. I wanted to, it was playing with speed density too was the other decision, and it worked out with the head limitations. And it'll still be somewhat of a noticeable idle, but it's still kind of the goal was like, let's see how much power I can make under 500,000s just porting the heads. I'll show that before I show any numbers. Let's see, photo to photo, these are all numbered. So here's an exhaust bowl. Camera's not totally picking that up, maybe I could put that on auto. That's pretty much finished work. Obviously you can see that I pretty much cut out the valve guide boss. This one I didn't go crazy with keeping my measurements. I just kind of went with the flow and then cloned them. I think the rule is about 85% of your valve face. You don't want to go really beyond that because you'll lose velocity. Now keep in mind, velocity and even CFM, the voodoo portion, because that's where voodoo comes from, is that term, I mean, an engine modification is like, you know, you could still have a faster car, and it really comes down to power band as kind of the definitive result. So that's kind of what you really want to look at. So I'm going to close that one. Let's see, I don't remember the order I did these. So you can see my, this is before the valves have been lapped or anything, or before I touch the intake. That's just an AFR catalog from like 15 years ago that I kept around for good luck, old push rods. But you can see I was cloning them up. They looked nice and pretty for this shot. The ports I went pretty large on because to fit the 1/5/8 header. Instead of squaring them out, I kind of went latitude-wise, you know, ceiling-wise, and got rid of the thermactors. And I ended up closing the thermactors with JB Weld, which of course I didn't have a photo that I opened up originally. Here you can see this is the truck plenum. It's tall enough to where I don't think that it even fits underneath a Thunderbird or a Mustang hood or an LTD, any car with a 5.0. Here's the dual 61, so you can see where I had to open up the ports. Now why this software is good is why you want to do this is I wanted to figure out what injectors I would need. The other reason maybe you haven't bought anything yet and you want to kind of see what cam is going to do what is as long as you have, like, especially if you have flow bench numbers, it's very accurate. The only thing that I feel is not as accurate with this build is my torque value because of the size of those long runners. So everything over here is I like to play around, and I'll show that when I show the numbers. Like I'll go to single plane or even tunnel ram and kind of get averages and means, but the torque isn't going to be as accurate because of that truck, as this is basing it off of mostly a single plane, and then they cut the power a little bit from electronic fuel injection. So next photo on the slide. So here you can see I just simply gasket matched this is what they call the dog legs, and you can kind of see that it looks like, I mean, very, very blotted out, but I guess you could see why that's called a dog leg. So I just wanted to port match the runners to the intake manifold, just what the hell, why not? So that's just blue. I actually just used blue acrylic paint, which actually was really great because it's very opaque. So in bright sunlight you can see it more so than like a transparent dye, because most of those are used for being able to etch when you're doing a radius on a valve. So that's how I marked it, very simple gasket match. Which I think this may change the profile because it's a low-end torque. I was hoping this would open up the mid to higher range, because then my intake manifold ports are ported and then the heads will be a little bit opened up. So you can see that here. So now you can see how much they opened up. So originally what I did is I had a cool photo of just opening the port. And here you can still kind of see a line that wasn't blended yet, but you could see how many millimeters were open and then before blending it. And the next photo will show how they're cloned up now. So originally, here's the intake manifold. Again, it's dog legs. I also got rid of these little casting notches. Just what the hell? They're just bothering me. The problem is, these areas are so thin right here. There's not really a gasket that can fit it, so this is pretty much all you can do with the dog legs. But now they're port matched, so it still opens up power flow. So the concept is from the throttle body through here, and then the intake ports are open, and then right into the intake bowl. So right from your foot on the gas pedal all the way to the intake bowl, everything is in harmony. Last three. Here's my intake bowl. You can kind of see the inside spring caliper. You use that to go from the outside diameter of the valve stem. You can see where I cut away the valve guide boss and kind of shaped that. It's a little more aerodynamic. I still have to do work on the short turn radius. See, the last video I had the cutouts open, and now I don't have that. Let me see if I can open that really quick. And okay, I do have that. Let me show that real quick. So this is cool. I found this on a forum because I was worried about water jackets. On the intake, you're not going to really go nuts in this area of the tunnel. Maybe if you're opening up the ports or going around, you can kind of see the push rod bump here, which this isn't a good way. You'd have to see it at a different angle. This is a water jacket here, and a lot of the airflow is opening up the bowl. Again, no more than like 85% or so of your valve face that you want to open this bowl. And then here's the guide boss from a cross section, and this is the short turn radius. You're doing a really bad job if you open up that water jacket. You don't even really need 50% of that, if that, maybe 35% taken off. It's really more about reshaping it than opening it. So these are really nice, and I have that intake and exhaust, and they're just cool to look at if you're interested in like head flow and design and venturi effect and all how they work. So I'll get rid of that one. Only a couple more here. Here you can see, notice how they look similar. I'll show you the tools how to do that. Not a great shot of the exhaust. I don't know if that one was fully done yet. Looks pretty gruesome there, and these look nice and pretty. I think I'm shining a light through them. But you can see the difference. This is blended here around the bowl because there is a hump here and there's not really water jacket. And then I take my inside spring caliper to go about 550 thousandths. You don't want to go nuts and lose velocity. Well, because not only do you lose your velocity, you're taking more time to do it, right? So you have to have a sweet spot for that. So let's see what the last photo is. Tools of the trade. These are $12 eBay carbide bits. The problem is if you go too fast, let them get hot. These you will lose cutting ability. This one ended up fusing because I was going way too fast. Because going from iron to aluminum is like hot butter. So once I was used to heads, I'm like, wow, the aluminum goes really fast, and I kind of ruined that. These are just to polish like a 250 and a 600 grit, another $14 item. You don't need to polish tunnels. That's kind of a misconception. Chambers are different because of detonation, but it's better to have a little porosity, like has been proven with dimples, is that you can increase velocity by having a rough surface. This is a 19th century inside spring caliper. I didn't get it because it's old. Patent was 1885, which I don't know, it could have been made in 1911, but this is necessary for the valve stem. This is how you measure your bowl distance from the valve stem. In the early stages, I used to use T gauges to check my ports and tunnels, and they're still handy, but The inside spring caliper overall is superior, but it's good to use both. And then a digital caliper. So it's again like a $12 item, and that's how you get measurements. Obviously, as a zeroing feature, you always want to make sure that you zero it out when it's closed, and it's standard and metric. Okay, so that's all. So, other areas, I don't know if I showed this. The compression ratio calculator, so you need to know your head chamber volume. The E7s are about 64 cc's. You would plug in. Gasket bore is about 4.100. And then gasket thickness, if it's like copper only, you're gonna be at like, 20 thousandths, maybe up to 40 or so for a regular one. And the smaller that value is, the more it's gonna increase your compression ratio. And I don't have my piston down bore, and also I'm on the wrong piston anyway. Is typically in the setup like this, you're gonna have valve reliefs. Still considered a flat regular head, or piston, but you need to have these measurements obviously when blueprinting, and it'll probably be around a 9.0 if I go with a, or 9.0 to 1, and if I do that. So now let's look at the numbers. The fun thing is you can do an auto run, but if you want to do a build and then hit run, like, so you don't see the numbers as you go. So again, this is a hydraulic flat tap at 306. It's EFI. It's the truck plenum, so the torque values aren't accurate. And let's see, I can go to the graph first. So here we see a very nice power band. Is nice broad low end torque, peaking around 46 to 48 or so. And in the truck, I put a valve in the AOD that'll do 5600. Maybe it'll be a little taller, or more than that taller. And then it peaks out at about 65, so you can tell it's a small block. Like, it definitely has some high-end power. Torque starts to slip off, but there's a sweet spot right there at about 55 or so, and that's about where we're shifting. So, and again, this is SFI, so you lose a little power than doing carb. So I like to play with those values, and I like to see what a roller cam would do. I wanted to keep the number modest for streetability. It still has good weight to power. It's still about a Ford Raptor. Like, it's definitely faster than a new Expedition. But this van, keep in mind, weighs just over 4,700 because the whole top is fiberglass. So let's look at the numbers. We have coming down right at our converter, which that'll probably be more because of the plenum, is, you're almost at 300 foot-pounds with the lockup converter all the way up. So we're hitting about 380 at 65. Torque, again, that's not an appropriate value. That'll probably be closer to 400. So that's pretty nice. I was hoping, every combo I've done, it's averaged, like, I usually hit north of 370. And again, I'm using someone else's flow bench results, and I've probably done a more thorough job on my head, but that's realistic, is under 400. Now, whoops. The thing to keep in mind, though, with a pushrod engine is this is equivalent in power band to having like a 410 plus horsepower Coyote. I've compared the power bands. This is usually making an average of 10 horsepower more per 1,000 RPM or 100. I forget how I measured it, but if you had this build in an identical 400 horsepower Coyote or so, or identical car, as this would typically win. So there it is. Like, that's all. The only thing I've changed on this engine is the camshaft, the lifters, push rods, roller rockers. It's technically stock forged connecting rods. It's a forged crank, stock compression ratio, ported plenum, ported intake, and heads. So it's not a lot has changed, even though a lot of work has gone into it. So it's nearly the stock engine. Now, if we play around here, instead of SFI, say, oh, it's a carburetor, single plane with 880, that's a little much for carb, but that is the value. It's 880 CFM is the correct value if you're running a 24 pound/hour injector. So now you can see that it jumps to 400, 406 technically. Now I can play with tunnel ram, 405. If I switch to roller, it's really funny. Well, on tunnel ram, I'll do SFI. So still with EFI, if I were going to a roller setup, which I did think of, but I want to keep the power at around 400 or less, you can see I hit 423, 392, and this is with doing port work on what came from the factory. So if you wanted to spend money, you know, it's like $200 to $300 just for a roller cam and stuff, yeah, you could definitely go over 400 naturally aspirated. And that's with SFI. If I go to a single plane, it really shoots up. So again, this is pretty accurate within, you know, I would say 5-10 horsepower. I've cloned other 302 builds with this software and hit the exact number at about the right RPM, give or take. But it's still a really valuable tool for knowing your power. The reason why you need to do that is to make decisions in your powertrain, so you're not spending a fortune on the transmission. Not that overkill is a bad thing, though I just saw that the fastest AOD car runs an 8-second quarter mile at 175 miles per hour. So any misconceptions you have about the AOD kind of being Swiss cheese is not necessarily true. You can definitely build an insane AOD. This build, like I said, it could probably handle more than 400, but because it's a truck, I just wanted it to all be heavy duty. And it's a 7.5 foot tall conversion van, so I really didn't want too much power. Again, it weighs 4,700 pounds. Comparable power plant, being in the brand new Expedition, is, you know, that weighs about 56. So this thing is, I don't know, 800-900 pounds lighter. And given the powertrain and whatever I do with the gearing, it's just a little scarier to accelerate with in a conversion van. So I wanted it to be streetable, you know, and the compression ratio is very manageable. This thing will run on 87 octane. You know, again, I'm getting a custom chip tuned for speed density. That was the other thing, is doing this all on speed density, stock valve size. I probably spent, you know, $50 or so on porting equipment. Like my rotary tool was like $20. One of those Nico, I highly recommend it. The thing, I've gotten that thing to about 100 degrees by using wire cup brushes on it, and it holds up. Like, I haven't burnt the motor out or anything yet. But yeah, that's desktop dyno. It's fun to play with. It's invaluable if you're building an engine, and it's very accurate if you can plug the numbers in and you know what you're doing. Except for, like I said, in this situation with our big plenum, the torque values are probably lower here, but the horsepower and power band is pretty appropriate. And it's a very nice, very decent truck power band, very pretty. And actually, realistically, this will be a little more toward this. So you have two even peaks. So it should be really nice, especially with the torque converter. So on a budget, you know, just to be caught up with you know, let's say a $40,000, $50,000 truck power, as far as like getting around, getting on the highway, you know, this kind of delivered. And it's just a old iron Windsor, you know, technology from the 60s outside of some, asymmetrical lobe design camshaft, and the lifter design is new, but it's still push rod iron head V8 in a truck that started life in 1979. So I'm pretty satisfied with what the software is telling me, and I'm very content with those figures out of a little 5.0. So anyway, so yeah, look for it. Google how you can download it, even if you have to pay for it. It's definitely worth it, and it's definitely fun to play with, and can really help educate you on lots of different engines and what to expect. And again, whether you're deciding to run a girdle or not, what injector to go with, whether to go I-beam, H-beam, all of the decisions that you have to make in a powertrain, this is really, really necessary to have. So yeah, that's all on that. Hopefully I covered everything. Again, it's desktop DYNO 2000. Nothing's changed about internal combustion, so it's 20-year-old software that still works, and because it's old software, it runs very, very fast on a modern machine. Not that it didn't before, but alright.